Welcome to today's super amazing science adventure. This video presents educational insights regarding a retrospective cohort study investigating IgM and IgG production among severe COVID-19 patients via qualitative and quantitative immunodiagnostic assays. Your body is like a castle, and IgG and IgM are the brave knights who protect it. Both IgG and IgM are types of antibodies involved in immune responses. IgM is the initial antibody produced during an infection, signaling recent exposure. It is essential for initial defense by neutralizing pathogens and activating other immune processes. IgM is the first knight, always the fastest to jump into action when danger strikes. Think of it like a fire alarm. It rings loudly to let everyone know there's trouble. IgG, on the other hand, is produced later in an infection. It provides long-term immunity by neutralizing pathogens and promoting their clearance. IgG levels are often measured to assess past exposure or immunity status. IgG is like a wise protector, arriving, a bit later, but staying for a long haul, keeping your castle safe forever and ever. It's like a magical shield that remembers the bad guys and kicks them if they try to come back. As we delve deeper into the article, we will encounter terms that may appear novel like a coronavirus to us. Wait a minute. That sounds like a bad dad joke. Well, anyways, let's hit the pause button and break down some fancy science words so we can easily catch up with the discussion. Dun, 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 dun. First up, immunoassays. An immunoassay is a laboratory test or procedure used to measure the presence, amount, or activity of a substance like antibodies IgG and IgM, which would be repeatedly mentioned in the video, and other biomarkers in biological samples such as blood. It can come in a form of qualitative assays which detect the presence or absence of a substance. It's like asking, "Hey, is there a treasure here? Yes or no?" And quantitative assays, which rather measures its concentration or amount. While quantitative assays gets all fancy and asks, "How much treasure did we find?" Next up, seroconversion. Oh, this one sounds cool, right? Seroconversion. Seroconversion is the process of antibody production against a specific pathogens such as virus or bacterium following infection or vaccination. It typically indicates pathogen exposure and immune response development. Seroconversion is often used as a marker to assess immunity or detect past infections in individuals. Now that we've cracked the codes on these sciencey words, it's time to level up and dive straight into our main quest, walking through the article. The article highlights the presence of antibodies IgG and IgM to analyze their possible roles in treating COVID-19 disease caused by the virus Severe Acute Respiratory Syndrome Coronavirus 2 or SARS-CoV-2. 3 immunoassays were utilized to drive the results: ABIT SARS-CoV-2 IgG assays, ANSH Labs IgG-IgM assays, and ACE-Colisa SARS-CoV-2 NPay assays. The findings suggest that IgG levels rose early and consistently, reaching 100 seroconversion 2 weeks after diagnosis. Wow! Talk about MVP material! While IgM detection was inconsistent and declined after 10 to 15 days. The findings affirm IgG's reliability for identifying past infections but posed skepticism about the utility of IgM and IgG immunoassays in early diagnosis or outcome prediction. The result emphasized the need for integrative screening strategies combining serological tests and PCR for effective COVID-19 monitoring. Using the qualitative test ABUT SARS-CoV-2 IgG assay and quantitative tests such as the ANSH Labs IgG IgM assays and ESCOLISA SARS-CoV-2 NP assays, the study analyzed IgG and IgM antibody production in 23 severe COVID-19 patients. IgG antibodies showed early and consistent production reaching 100% seroconversion by 15 days post-diagnosis with a strong agreement between test methods. In contrast, IgM production was inconsistent, peaking at 10 to 15 days and declining later. Wait, why the inconsistency with IgM? The study rationalized that this may be due to the serological testing being done at the later phase of infection where IgM antibodies are almost non-existent. As we can remember, it was earlier mentioned in the video that IgM only appears during early infection for initial defense. Hence, this may not totally sound illogical. Now hold on to your hats because here comes a twist that might surprise you. It is important to note that the study shows no significant link between antibody levels and mortality through various statistical treatments used for different data, such as the Wilcoxon signed rank test, Mann-Whitney-U test, and repeated measure ANOVA. Whew, that's a mouthful. It reiterates similar antibody kinetics in severe and non-severe cases. Hence, it implies that antibody production does not influence the survivability of COVID-19 patients. With this, the study recommends more rigorous research on new viral variants. But wait, let's not forget our dynamic duo, IgM and IgG, the real MVPs in our immune system. Despite the lack of relationship, we should not overlook IgG and IgM's crucial role during infection. IgM, although short-lived, is the early responder that acts as an initial defense when the body detects a pathogen. It is effective in forming antibody complexes and neutralizing pathogens during the acute phase of infections. Moreover, IgG, although appears longer, serves for long-term immunity and dominates in subsequent exposure to the same pathogen. We can also say that it acts with versatility just like IgM. It also neutralizes pathogens. Even more, it activates complements and enhances phagocytosis. To end this video and this amazing semester, one important takeaway we should keep in mind is that immunology teaches us that we are never alone in our fight. When we're under attack by an unknown enemy, we've got some invisible friends fight for us in a ways we don't see. They are tiny little warriors who have our back. They are heroes who don't wear a cap. They are our antibodies. Get it? Antibody? Antibodies? Okay. I think that doesn't sound too bad for a dad joke. Remember, science is awesome, and so are you. So keep exploring and stay curious. Don't forget to thank your superhero selves for all they do. See you next time on Immune Adventure Express. Bye!